Hi guys, so today I will talk about Imagen. Basically, in the previous video, I have also shown a video of text to image generation. So in this video again, I am talking about the latest model, which is based on Google research, and the name of the model is Imagen. So as you can see on my screen, I will show you some content and the research around it. So basically this is the Imagen model, and beside this again the workflow of this model is something like, so when you pass any text to the model, it will generate an image respective to your given text. So this is again generated by this is the Google research, as you can see on the screen, and this is trained on very large text. They are using very text encoder for this, and this is this is the Google search, and this is the particular research paper. If you want to extend this, so you can also go through this. Here you can find the research paper of what text to image, and what model they are using. So currently this code is not open source yet. They're not publicated, but you can reference, you can take it as a reference, and then you can build up your model by your own. So this is the reference page, as you can see on the screen. So this is the text, and in the right hand side the image generation basis on the text. So again, in this model they have briefly talked about the model they have used for this, for text encoder. They are used large encoders T5 model, and basically on the backend side they have used corpus data, and moreover they have also used coco data set for this. And moreover you can also go with on the previous version of this text to image, like VQGAN plus clip model and diffusions models and DALL-E 2 models. So users rated this image gain model as much better than with this previous model. And this model have better accuracy and better result generation as per the previous models. So basically we are focusing on high quality images from the text, and basically this is the model where we are getting the images with the better resolution and with the better quality, as well as with the better alignment. So this is the, you can see as a reference, and they also show the drawbench and the research paper around it as I show you. So you can also refer to this. This is the random images of they have generated with the help of the text. You can see in the text shown in the just uh, down to the image, you can saw the text, and you can check the results generation. Also they have also applied different styles. Likewise, if you want to create image of a different style, so you can also do that as well as. So this is the basically you can say workflow of how it works, when you pass it as text, and how will it will generate into a higher resolution side. So basically in build they are using different side of super resolution model and text to image diffusion model. So initially you have to pass 64.64 image, and later on it will convert. Once the model is will generate the result, it will upscale to this resolution. So this is the brief about the workflow, how you can further utilize the images into higher scale, and how you can compute this into a super resolution model. So this is the basic workflow, and the next one is they mention some highlights of this model, how this model is better from the other, and what are the differences. So you can see on the screen. So basically they have used the frozen text encoder, and again, as I told you, that it's trained on very on the large scale. And most probably again we are focusing on the results. So that's the next the highlight of this model, that the result generation are much prettier and much clear with as per the reference of previous models. and in this they have used UNet. So basically UNet is, you can say, a convolutional neural network. Initially this model was created for biomedical purpose, like in which you can detect the type of function or area of the function, like infection in the body. So like this is the initial purpose, but now you can use it as global location detection, or you can use it you know like further locations of further aspects of AI. Now it's also used in text to image purpose. So the main advantage of using this, that it has very less parameter and it will execute with the lesser parameter, but gives us as a higher quality of picture, high quality of results. So that's why we like Google prefer this architecture, like UNet. So you can, and moreover this is, again the faster mode, faster neural network, like as per the result generation. So you can prefer this unit architecture. And this is again the comparison of image generation with the other model. So you can see the difference, how like image generation model is faster and accurate with the reference to the models. So as I'm talking about, style applying, like they have applied certain styles on this. So this is the like reference. As a reference you can follow this, like as a photo of an oil painting of like of an animal, of an object. So you can find this as for like Fuzzy Panda. So any sort of text you want to like pass to this model, it will generate a result of something like this style that you want to add. As of now this code is not at public, so like you need to like wait for the public or for the open source model, or you can refer any of the previous model and you can modify it according to the code, and you can finally work on this implementation. As a limitation, as a social impact, so as of now, like the Google research team and the brain team like specify this limitation as this particular the text is limited to a certain area of texting. Likewise, they have not focused on pornographic images and toxic languages, as well as they have restricted this text basis on harmful social stereotypes. So this is, you cannot say as limitation, but yes, as a social impact, it will not create such images from the text which is based on one of these options. And the second is again, the next limitation is like you can drop any of this option. Likewise, you can like social base evolution method is the one of the option, and the second one is like uh, the next step is to fix the progress of like this, because as they are starting with very limited text and with the lower skill side of images. So maybe it will create noise, like when we scale to upscale, or maybe we generate with the like we're merging with different models. So maybe there will be a noise in the accuracy and in the result section. But you can drop, or you can, maybe the issue with the data distribution is starting from the input to the final output, because like every image is certain images, and like every images has certain data, and so maybe that's cause issue. But again, the first one is like I can also relate with the first option, that they are not focusing on this type of texting. So there also, that will create an impact on the social. So that's not the major. So this is again an example they are sharing on this. So like you can see the results, and you can see the variations, and you can also see the styles applied on this. So this is the special thanks and offer. So basically this is the reference page of like Imagen, which is based on Google research and the brain team. And you can also follow the research paper and the draw bench for this model. Okay, so the next point is, this is the research paper as I already shown you. Okay, so the next thing is, like, you can also google this as Imagen. So like, I have found one of the model which is based on Google's text to image neural network in PyTorch. This is not like, you can say, updated version, like they don't have the updated version of code, but yes, as I told you, that you can follow as this model as base model, and then further you can do implementation. So like, this is the initial page, or you can see the front page of this model. I have already implemented this model. Then I will also show you the how, like, it will go around the work. So in this section, in the user section, they have not mentioned as how you can write images after generation. So this is the basic the interface of coding this model. So I've implemented this into as my Google Colab Pro account, and I now have cloned this. And you need to install Imagen as PyTorch. And so this is the next cell is about to talk about the code version. So as I told you, that this code is basically worked on unit architecture or neural network. So in this, these are the parameters, these are the layers in which they have defined the dimensions of the image and the layers of this neural network. So like, you can go with, or you can tweak this hyperparameter. And this is the, like, super resolution ones, like they used text encoder and super resolution for upscaling the image. So in this, you can see T5 large image they have used as text encoder. And like, image size will be on the initial level, image size will be on 64 cross 64, but later on it will give 256, and at the last it will give as 1024. Here I have tested this model on the different time steps. Like, initially I've tested with let's say 100, 1000, 1500, 5000, 50,000, 1 lakh, and again then this number that is called 50,000. So like, till the time I've not received any any image which shows that the results are much better. But again, we need to train this model on the bigger side, on the bigger number, so that will for sure generate an image. So this is the classes. So you can also prefer as Cocos as seen on the screen. So this is they have also used the Coco dataset. So Coco dataset is based on like, trained on more than 80 plus classes. So you can also, like, understand the Coco dataset, how it can depend on the classes, and what is the object detection method, segmentation method around the Coco. So these are the the training parameter in the cascade, where you can pass the text embedding, text marks, mask, or you can say a segmentation, number of batch size. So here I am using number of, this is the basically the default parameter, but you can tweak with your parameter. So in the last, I have saved this images. So image 1, so this is how it works, and it goes around the number of time steps that you have mentioned in the code. So this is the basic workflow of this model. So like, I have saved this images, but the images are very noisy in the frame, so the objects are not visible clearly. But again, you can, if you train this on the higher scale, maybe you will receive the better image as per the resolution. So this is the basic workflow, and this is the image. Again, if you have any doubt, or if you like the video, so you can mention in the comment box, or you can approach me on LinkedIn, or you can approach me on my YouTube channel or GitHub. So thank you so much, and I hope you like the video and you find this video as more informative. So thank you, and I'll see you in the next video. Thanks.